Hey, hi everyone, and welcome to our final project presentation, Snake Game AI using Deep Q Learning versus PPO algorithms. And I'm Akash, the ML developer, and I am presenting today with Naveen and Ganesh. In this project, we set out to explore how reinforcement learning can be used to train an AI to play the classic Snake game efficiently. And here is our team. I led the machine learning implementations and part of things, and Naveen worked on the data engineering part. In addition to that, Ganesh focused on the game design and visual outputs. Our main motivation was to understand how model-free reinforcement learning can help an agent to learn, survive, and thrive in a dynamic environment like Snake with no hard-coded rules. We choose to compare two our approaches for this. One is deep Q learning, which is a value-based method, and another one is a proximal policy optimization, also called as PPO algorithm. It is a policy-based one, as name suggests. So our entire project, we structured around our work around three research questions. The one is, can RL agent learn Snake purely through interaction without supervision? And another one is, how do DQN and PPO differ in terms of learning speed and stability? And the final question is, can these agents generalize to new or less frequent game states like that? Our key objective was to train and evaluate both DQN and BPO in the same environment and compare their performances using quantitative matrices like episode scores, rewards, averages, and convergence behavior. The tools and technologies we are used in this entire project is Python, PyTorch, Pygame, NumPy, Pandas, MATLAB, and GitHub for version control. The Python we used for as a core language. The Python we use as a core language. Python used for model training, Pygame for creating snake and game environment, NumPy, Pandas, Matplotlib. These we use for numerical operations and visualizations. GitHub for collaboration and version controls. And the overview here is and the overview of the game is how game works. The snake moves in four directions and it eats food and grows. One food item appears at a time, and the game ends if the snake hits a wall or itself. The agent goal is to maximize score by surviving longer and collecting food intelligently. From here, my teammate Navin will take care.
Thanks for the introductory part, Akash. I'll now explain the core learning flow and the two agents we train, DQN and PPO. This is the reinforcement learning loop we use for our snake game. The environment generates a state, like food location, danger, and direction. The agent, DQN or PPO, takes this state and picks an action to move straight, left, or right. The environment returns a new state and a reward, positive for eating, negative for crashing. This cycle repeats for thousands of steps, helping the agent learn what works best. This is how we structured the project. Input preprocessing converts the game state into 11 binary features. The decision module, DQN or PPO, selects the best action. Rewards are calculated and sent back to the model. We log scores and rewards for analysis. This modular approach helped us easily switch algorithms and debug issues during training. DQN is a value-based method. It uses a neutral network to predict Q values for each possible action. We used 11 binary inputs: danger detection, direction, and food position. The model outputs Q values for to move straight, turn left, or right. We used experience replay to sample past moves and greedy policy to balance exploration. It showed fast learning, but performance was unstable with spikes during training. PPO agent. PPO is a policy-based method. It doesn't estimate Q values. Instead, it learns action probabilities using a softmax layer. Actions are sampled stochastically. After each episode, it computes returns and advantages and updates the model using a clip loss function to ensure stability. PPO learned more slowly but gave smoother and more consistent results. Evaluation metrics. To compare both agents, we tracked average reward, score progression, learning speed, and training stability. These gave us a balanced view of performance and reliability. Now, going to comparison and insights, DQN learns faster but is unstable, with sharp spikes and drops. PPO is slower but learning is more stable and reliable. Both eventually performed well, but PPO was the more robust choice overall. Now my friend Ganesh will take over.